In this video, you will learn how to solve for the value of x in this nice cubical equation. Now we are asked to find the value of x. Don't forget to give this video a thumbs up. Also, kindly subscribe to my channel for more unique mathematics content. Now, to solve this question, the first thing that will come to your mind is to think about making this a truly cubical or a polynomial equation. And what you need to do is to bring the value of 350 to the left hand side. So let's subtract 350 from both sides. So if we subtract 350 from both sides, we're going to have x to the power of 3 plus x minus 350, and this will be equal to 0. Great. So having done that, the next thing that should come to our broad mind is to look for how we can solve this question using the principles of polynomial. But I'm going to apply a simple logic, and with that logic I can be able to come or to find the first solution and the quadratic solution to this expression. Now let's come to see the number minus 350. Minus 350 can be separated to give us negative 343, right? Negative 343 minus 7 will give us 350. Now why do I use negative 343? Now let's analyze negative 343. If we analyze negative 343, you find out that 7 can be divisible by 343, and that will give us 49, right? If 7 goes again, it will give us 7, and if 7 divides 7, we're going to have 1. So we have all this to give us 7 to the power of 3. So that means I can simply replace my negative 343 with 7 to the power of 3 minus what? 7. So that expression will now give me my x to the power of 3 plus x minus 7 to the power of 3 minus 7, and this will be equal to 0. Great. So now you see I have quietly simplified that expression. Now, having simplified that expression, the next thing I will need to do is to bring the common terms together. So I'll have x to the power of 3 minus 7 to the power of 3 plus x minus 7, and this will be equal to 3. Now I want to flash your mind back to an algebraic expression. In that algebraic formula, we have a to the power of 3 minus b to the power of 3. Now, if we are given this can be equal to a minus b as the first solution, and then we'll have a squared plus ab plus 7 plus b what? B squared. Right, good. So if that is given, we'll see that our x in this instance is equal to, or our a in this distance is equal to x, and then our b in this instance is equal to what? 7. So let's substitute that into that expression. So we have x to the power of 7, x to the power of 3 minus 7 to the power of 3. So that will simply give me x minus 7, right? And then I'll have left x squared plus 7 times x, which is 7x, plus 7 squared, right? That completes that equation. So this other one will give me plus 1 multiplied by x minus 7, and all this will be equal to 0. So I've expanded that expression up there. So having done this, you see something at x minus 7 and x minus 7 is common in this expression. So let's bring out x minus 7. If I bring out x minus 7, that other expression will now give us x squared plus 7x plus 7 squared is 49. Then if x divided by 7 divides this whole part, we're going to have plus 1 remaining, and all of these will be equal to 0. Remember, if all this divides x divided by 7, we'll have this whole thing remaining, right? And that is how we got that expression. Now you come to notice that we have what we call the zero product rule applied here. So we have our x minus 7, which will give us our first expression, and then we'll have x squared plus 7x plus 49 plus 1 is going to be 50, and this will be equal to 0. So if we apply the product rule, we'll have our first case to be x minus 7 to be equal to 0, and we'll have our second case to be x squared plus 7x plus 50 to be equal to 0. So you see, just like the solution of a polynomial will give me one solution and a quadratic equation, this solution has given me one solution and a quadratic equation. Now let's solve the first solution by adding 7 to both sides. So we'll have our x minus 7 plus 7, and that will be equal to 0 plus 7. So if we do that, this will clear this, and then our x will be equal to 7. So our x equal to 7 is the first solution to that exponential equation given to us. So the next solution we are going to find by solving this quadratic equation, and from this quadratic equation we're going to solve it using the quadratic formula. If we solve this quadratic formula, solve this equation using the quadratic formula, what are we going to have? We'll have our a to be equal to 1, our b will be equal to 7, and our c will be equal to 50. Now remember or recall the algebraic formula. We'll have the value of our x to be equal to negative b plus or minus square root of b squared minus 4ac, and that will be divided by 2a. So if we simplify this, we are going to have those expressions, values of a, b, and c substituted into that expression. So we'll have our x to be equal to minus 7 plus or minus the square root of 7 squared minus 4 multiplied by 1 multiplied by 50, and this will be divided by 2 multiplied by 1. So if we simplify that, we're going to have the value of our x to be equal to negative 7 plus or minus the square root of 49 minus, this is going to give me 200, and this will be divided by 2. So 49 minus 200 is definitely going to give me a negative value. So our x is equal to negative 7 plus or minus the square root of negative 151 divided by 2. So we can separate that value to give us our x to be equal to negative 7 plus or minus the square root of 151 multiplied by the square root of negative 1, and this will be divided by 2. Now recall that the square root of negative 1 is always equal to an imaginary. So if we apply that over here, our value of x will be equal to negative 7 plus or minus square root of 151 imaginary divided by 2. So let's separate that expression. The value of our x will now be equal to x is equal to negative 7 plus or minus square root of 151 imaginary divided by 2. So we're going to make this to be the positive side of it, and this can also be -7 minus square root of 151 imaginary, and this will be equal to 2. Now you come to see that these two solutions are imaginary solutions. They are imaginary roots, and as a result of that, the fact that they are not real solution, we are simply going to do what? We are simply going to neglect them. The only real solution we have, as found earlier on, is x equal to 7, and that is the only real solution we have for that exponential expression that is given to us up there. Now let's test to see if this solution is actually correct. To test, we are going to insert the value of x equal to 4 into our original expression. The original expression we are given that x to the power of 3 plus x equal to 350. Now if we insert the value of x, are we going to get 350? Now 7 to the power of 3 plus 7, will it give us 350? Let's check. 7 to the power of 7 will give us 343 plus 7. Will it give us 350? Yeah, it will give us 350. So this will be 350 equal to 350. So that tells us that x equal to 7 is a solution that truly satisfies that exponential equation that is given to us, minus the what? The imaginary solution which we have gotten from the quadratic equation that we got during the solution. I know you did enjoy this math solution. Don't forget to give it a thumbs up, share it with friends and colleagues, and also remember to subscribe to our channel for more simplified mathematics content. Thank you so much for watching, and bye bye for now.